Welcome to Spring LIB.
Here, we need to find the spring constant. So we know that the work of the spring is going to be equal to the change in kinetic energy, and this will be equal to 1/2 times m v final squared minus v initial squared. And we know that this is coming to a stop, so the final velocity will be 0. And we can say that the work done by the spring is 1/2 kx squared, and this is equaling negative 1/2 mv initial squared. So essentially, we know that x is going to be equal to v initial times the square root of the mass divided by the spring constant. And we know that force is equaling the mass times acceleration, which will equal negative kx. And here we can say that mass times negative 5.0 g is going to be equal to negative k times v initial times the square root of m over k. So here we're substituting negative 5 times the acceleration due to gravity for the acceleration. And then for x, here we're substituting this equation here. And then at that point, we can solve for k, and k is going to equal m times 5g divided by v initial quantity squared, and we can solve. So let's get a new workbook actually, and say that k is going to be equal to 1,300 kilograms times 25 times 9.8 meters per second squared, all divided by 90 kilometers per hour multiplied by 1,000 meters per kilometer. And then there, for every 1 hour, there are 3,600 seconds. And then we're going to have to square this entire term. So we find that after evaluating, the spring constant is going to be equal to 5.0 times 10 to the third newtons per meter. And so this would be our final answer. That is the end of the solution. Thank you for watching.